Hi, and welcome to Module 2, an Introduction to Natural Language Processing, or NLP. Here's what you'll learn about in this module. In the first section, you'll learn about how the machine learning pipeline, or ML pipeline, changes for NLP problems. The next section provides a summary of some common NLP tasks you'll perform in the course. The third section walks through a typical NLP problem. And finally, you'll learn about the history of NLP and how ML and deep learning have improved NLP capabilities. Okay, it's time to get started. At the end of this module, you should be able to describe how the ML pipeline can be applied to NLP. You should be able to identify common NLP tasks. Use the ML pipeline on an NLP problem. And summarize NLP architectures. This section covers NLP and machine learning. You can apply the same ML pipeline you learned about in AWS Academy Machine Learning Foundations to NLP problems. In this section, you'll review each stage of the pipeline and learn some of the key differences for working on NLP solutions. The first task for all ML problems is to formulate the problem. In this stage, you'll make sure that the problem is actually an NLP problem, and that you have a suitable data set to address the problem. You should also work with business stakeholders to get a clear definition of success metrics and brainstorm on the simplest way to solve the problem. The next step is to collect data. Data for NLP can come from databases or earlier systems, documentation, or websites. Data can be simply text or a combination of text and other data types. Collecting NLP data from databases or earlier systems isn't any different than collecting regular data. You can collect, ingest, and transform data from multiple systems into a single location using AWS services like AWS Glue. You can also use techniques for extracting, transforming, and loading data, which is known as ETL. Sometimes you'll work with paper documents, either handwritten or typed. These documents will need scanning, and with handwritten text, you might also need to use ML to identify the letters and symbols. For audio and video, you might need to transcribe the speech with a service such as Amazon Transcribe. If the data is in different or multiple languages, you might need to translate it before you do any further processing. One thing to be aware of is that the text data often won't be labeled for working with ML models. As such, you'll use more unsupervised models in your NLP solutions. When you evaluate data, you'll need to analyze the text elements to identify characteristics that might impact your solution. The following list isn't exhaustive, but some of the most important things you need to determine are: what languages are in the data? Languages have many differences that impact the process. For example, many European languages are structured differently than many Asian languages. Having a consistent language will help you solve problems with a higher degree of accuracy. Next, you'll need to consider the writing style. Is the text a formal scientific journal, a blog post, or a social media post? The writing style can impact how you process your data. For example, when you work with social media posts, you'll need to decide how to deal with emojis, sarcasm, and slang. You might also need to expand acronyms depending on your scenario. Another aspect to consider is whether your data has incorrect spelling. Having the correct spelling will improve results. You'll also need to determine how to handle special characters. You might need to remove or convert special characters to process the data correctly, such as emojis, punctuation, and mathematical symbols or formulas. For example, a thumbs up emoji and the word great might express the same meaning in your problem domain. Next, you should consider domain-specific terms. It's important to understand what terms you have and how they might impact the results. For example, a common task is removing stop words such as the, and, do, or don't. However, removing these words can cause problems in sentiment analysis, where do and don't could change the sentiment of a statement. Finally, you should consider word forms. You'll need to decide whether to convert different forms of a word to a common format. This process could be converting forms of the same word into a common format, such as converting run, runner, and running into run. It could also be more sophisticated, converting similar words into a standard word. For example, good, great, brilliant, and better could all be represented as good. After you evaluate the data, you'll need to perform some processing to extract the features you need. First, you'll need to process the text. Here are some of the tasks you'll perform in processing. Normalization. This includes several text processing steps, from converting text to lowercase to removing punctuation. You'll learn about many of these steps in the next module. But for now, you can think of normalization as cleaning up the text to make it consistent across your data. Stemming. This is a method for changing different forms of a word into a standard form. For example, you might change run, runner, and running into run. Lemmatization is another technique. It converts similar words such as good, great, and better into a single common word, like good. After you process your data, the final step is converting the text into numeric values. You can do this in different ways, depending on the problem you're trying to solve. You'll learn about many of these techniques throughout this course. But for now, you can imagine that each word in the text is converted to a column of numbers. It's worth mentioning here that you'll often end up with data sets that contain hundreds of columns. After you've defined your data set, the process is the same as the regular ML pipeline. You'll split the data into multiple sets for training, testing, and validation. Next, you'll select and train a model. You'll assess the model against the business goal by using the metrics provided by the algorithm, or by calculating your own. You might then tune the model by updating the model's hyperparameters, or by changing how you process the data. You'll then repeat this process many times and use the metrics to find the best performing model. It's important to determine if the solution meets the business goal. Using metrics can be a good way to determine this, but you need to understand which metrics to use, which depend on your goal. You'll learn about this process in more detail when you go through the walkthrough that's in the next section. Finally, you'll deploy, monitor, and maintain your model. Amazon SageMaker has features that make this process easier to manage, but these features are beyond the scope of this course. Thanks for watching. In the next video, you'll get an overview of some of the most common NLP tasks.